welcome everybody. I have the pleasure to say hello to you for today's talk about have you secured your DevOps recently? I'm your host for this session. My name is Niels Oliver Linden. If you have any questions during the talk and you're not here, please feel free to post your questions in the corresponding Slack channel. In the end, we will have a short time where we can address your questions. And with that, I have the pleasure to introduce to you our two speakers. On the one hand, Benjamin Goose. And it's a very pleasure to introduce him because he's one of the rare species at TNG because he has not the classical background. He studied music and also did his PhD in music in London. And then somehow he found the way to software development. And for 10 years now, he's working at TNG as one of our principal consultants. And that basically gave him the chance to see a lot of different projects, especially in the cloud. He focused there particularly on security, also in the DevOps area. And that means we can today learn a lot from him. And on the other hand, we have Christoph Niehoff, which is a more classical TNG consultant. He studied physics and also did his PhD here in Munich at the TU. And he's now working for TNG for 4 years. And also when you look at his time at TNG, you see that he typically have encountered all the buzzwords which you actually want to have at somebody who should talk about security. That means you see IoT devices, you see DevOps, you see microservice infrastructure. So I'm also pretty sure that he knows what he's talking about. And with that, have fun with today's talk about have you secured your DevOps recently?
Thank you, Niels Oliver. So this talk today is not about how to do ransomware attacks on AWS software or how to escape the Azure container runtime. That's all the entertaining stuff. It's fun to hear tales about that, at least if you're not on the wrong end of an attack. But it's not the topic for today. We're not even going to tell you how to defend against those attacks, at least not specifically. What we want to talk about today is much more basic than that. It's about the things that you and we have to do to protect our DevOps infrastructure, to make sure that attacks like that and all the other possible attacks have the least possible impact on you. Now, why this? Why this topic now? Well, let's have a show of hands. Who does DevOps at the moment? Okay, it's a bit of a self-selecting audience, I see, but still, there's a lot of hands there. And it's something we notice at TNG as well. Many of our clients, just as they're moving to the cloud, are also moving to DevOps. And at least if they don't do it already, are planning to do it in the near future. Now, on this topic, the term DevSecOps has been making the rounds in recent years. It's a bit of a funny term. It makes the idea of security explicit, and that's a good thing. But you might also ask, is DevOps just DevSecOps without any security in it? If you've been doing DevOps, your team is responsible for the product. Does that mean you're not responsible for the security? Is that okay? Well, most likely you haven't been doing that, or you'd have had some pretty big disasters. So what have we been doing? We've been doing DevOps securely, and that's what this talk is about today. It's about secure DevOps, the only kind of DevOps there should be. And we're going to do that using a fictional and abstract system, of which I am the fictional and not abstract developer. And we'll be using this to show you some of the threats and some of the measures that you might have to take if you're doing DevOps in a cloud context. That's not to say it isn't a real system, though. All the things we talk about are out there somewhere. We have them in our projects, and you have them in your projects. And with that, I will introduce my colleague, Christoph, who, for today, as a hugely convincing hacker, will be known as Chris the Hacker.
Hi, I'm Chris the Hacker, and maybe I should introduce myself a little bit. So some time ago, I've also been a software developer, but then I found that my just enormous skills are much more profitable if I use a different business model, and that's why I became a professional hacker. And yeah, you can give me just any target on the internet, web server, web shop, whatever. I actually don't really care that much. And it's my job to hack my way into it. Yeah, and I'm pretty good at it. And so as long as the financial incentive goes, my resources are kind of unlimited. So I'm backed up by a large crowd of hacker friends, and I'm also running my own botnet. So hot hardware is of no concern for me. But today I'm here for a pedagogical mission. So I would like to invite you to join me for one working day and see what I'm be doing. But yeah, don't be afraid. This won't take too long, and I like short working days. So my target is usually hacked in a couple of minutes. And yeah, I also recently bought my own Caribbean island, so I like to work from my own beach. So I want to go there. So let's just get down to business. So let's hack. So that's what we're looking at today. It's the production environment of Ben's application. And let's just brainstorm a little bit. So what does it mean that an application is exposed to the wild and evil internet? So usually people are crazy when they put their things online because there are lots of open ports and open maintenance entities and all this. And this just leaves you with a server which is usually hacked as easily as an open barn door. So if that's the case, we can just do as we all learned in our web hacking 101 classes, and we can just spin up our reconnaissance and scanning tools, and yeah, we can take a closer look. And with that, we'll just get all the intelligence that we need to do the hack. So we will learn what operating systems are used and what technologies and what versions of these. So we can just, if we're lucky, we can just look these things up in the exploit DB, and if we find something, we'll be done for today. But we'll also see if there are any open maintenance channels like a badly secured SSH or some Windows remote desktop thing, or if there's other stuff like direct access to databases and all these kinds of things. And most importantly, we will also see what else is running on the server, because usually admins run tons of stuff on their machines, and this just then dramatically increases the attack surface, and there's usually always something that will just let me in. So let's just start, and I'll just spin up my scanning tools, and we'll see. And oh, what's this? I don't really see that much. Oh, Ben, don't tell me you are using the cloud, are you?
Right, we're in the cloud. And what does this mean? Does it mean we're in the cloud and therefore we're safe? Is that what we're claiming? Well, you can do a lot of things wrong in the cloud. You can have S3 buckets that are entirely unsecured. You can create queues in the cloud that anyone can write to. And then any hacker can push messages into your system. Those are all mistakes that people have made, and they're all out there somewhere. They're still out there. But in the cloud, it's also relatively easy to do the right thing. This is because so much of the actual maintenance work is abstracted away from you. So we have our application here hidden away in this private subnet here. So whatever, containers, servers, some kind of Kubernetes workers, they're all there inaccessible, so they can't call out and you can't call back in. The only ingress here is our load balancer at the top, which exposes one HTTPS port. And the cloud provider takes care of certificate rotation, takes care of secure ciphers, takes care of availability. We have a web application firewall from the cloud. So this stuff is all there. And that effectively reduces the attack surface to the place that users are actually supposed to be able to access on the application. These backdoors, these careless things that let hackers find an easy way in, they're not there in our application. And since we don't do anything particularly complicated in our application, we're fairly confident that we've stuck to best practice. We've used all the tools and the guidelines that are out there, the things that cloud providers give to us so we can assess our infrastructure. And we're fairly sure that we don't have any glaring holes in our infrastructure for Chris the hacker to exploit.
Okay. So I have to admit that this may take a little bit more effort than at first estimated. So if this app doesn't really run on some old garage software hardware, but in a professional cloud data center. So it seems today we'll have to roll up our sleeves and start to work for our money. So let's go to bread and butter hacking and hack the application like in the traditional way. So let's assume that the developers of the application, they didn't really care about implementing it with a security focus, or that they didn't really know what they were doing, or maybe management didn't give them enough time or priority to implement the app with a security focus, because just building features might be more prestigious. So maybe the app itself has some serious security flaws that I can exploit. So it's got a reason why OWASP is keep publishing its top 10 of web vulnerabilities every year. So maybe you can just try to exploit one of the services that the application exposes, or we can use some kind of a 0-day, or what about good old SQL injection? Maybe we can inject a command and get it run on the server. Or maybe we can just tamper around with user management. We can forge some tokens, or we can somehow escalate our privileges. I mean, there are tons of possibilities that we can do now. And well, I'm pretty sure Ben didn't have time to consider these all.
Right, well, time is exactly the issue here. There are so many things to consider here. There are so many different ways of attacking an application. And how do we fit them all in? Well, one thing that DevSecOps emphasizes is moving security left. And this here, the left part of the DevOps lifecycle, the dev part of things, the creation, the planning of the software, the testing and the packaging, this is the part that we move security towards, rather than picking it up when it's already on production. The further the left, the earlier in the life cycle of the software. Why move security left? Well, mostly because the earlier you start something, the easier it is to do. It's rarely easy to tack anything on once you've actually implemented it. And security, at the very least, because this is something that usually goes right to the heart of the software architecture. But another reason is that this is simply the part we're used to. We've been doing development for years, long before terms like DevOps came up. And we're used to this kind of stuff. It's what happens in this part of the software lifecycle is familiar and predictable. It's something we can plan a little bit in advance. And it's safe because it hasn't yet been released to production. And that's particularly because we have our automated build pipelines to back us up. And there's a range of security-related tests that we can put in here. We check, for instance, the simple things with static analysis, find bugs, SonarQube, cast, all this kind of software. And we concentrate on those reliable rules, the rules that allow us to find the important stuff without throwing up too many false positives, so that we catch things like memory leaks, segmentation faults, or injection errors before they get to production. Or we check for secrets that are checked into source code. And particularly because it's easy to implement this, it's easy to integrate it into a build pipeline. This is something that almost all CI/CD tooling offers. Functional tests, though, are something you also shouldn't forget, because these are often things that don't catch the poor programming practice, they catch the logical errors we might have made. We test, for instance, that our users don't have access to each other's data. We test authorization concepts. And even load tests are critical here, because availability is another part of security. And if Chris the hacker can take our application offline whenever he wants, then we have a problem. So we run our load tests regularly. And here, the whole point is automation. Automation is what saves us the time. You put as much as you possibly can into your build pipelines, and then make sure that the developers have this security of the safety of knowing that what they've developed is being tested. But still, there are some things you can't yet automate properly. Code reviews, making sure that you have a simple and well understood process for someone to review all your code will still catch many things that tools yet can't, that a computer can't find. And while we're talking about best practices in development, let's give a mention to pen testing here, pen testing is something that is critical to a system. It is really important to have professionals look at your software and see if they can find things that your developers may have missed. But it's too late. At this point, your system is most likely very close to or already on production. And that's, again, not the time when you want to start building security in. So we need to move security even further to the left. Pen testing should not be your first line of defense. Yeah, back to our automated pipelines. These are really the heart of a good DevOps setup. Developing should be something that's easy. It should be simple to give developers the confidence that their changes will be well tested. And we put everything here. We have our cloud best practice compliance checks. We have container scans. We even have spell checks here. That's not particularly security related, but you can really put anything in a software build pipeline. But this is not the beginning of the software lifecycle. Before the build pipeline comes this phase of design and writing of software. And although it's not as linear as this DevOps cycle shows, it's lots of smaller cycles of building, testing, verification, and packaging, even deployment. It is this part of the DevOps lifecycle that the build pipeline exists in. And if you take things like a bug at an interface boundary where each component assumes the other will take care of authorization, and then neither of them does it, how does this get caught by your build pipeline? It's a logical error that actually needs someone to think about it further. So security has to be right at the built in right at the beginning of this life cycle. And what should we do about this? Well, it so happens that Chris the hacker here can take off his black hat for a second and tell us something about it.
Yeah, one thing that I can tell you is that people often don't anticipate me as an attacker when building the software. I mean, maybe a pen tester does, but not so the real expert of the application. And these are the developers, because no one knows the system better than the people who actually built it. So if a developer looks through an attacker's eyes on the system, this is just worth gold. And a great way to include developers into security is threat modeling. So every vulnerability that is there in your system and that can harm your system is a threat. And threat modeling is all about finding these threats, enumerating them, and finding ways to deal with them. And what you want to have is kind of a systematic approach to do threat modeling. And I mean, the obvious way is to run some long list of known threats against your system. And yeah, and I mean, this might not be the most fun thing to do, but it does its job. I mean, it gives you a lot of different perspectives on your system from a security point of view. And most importantly, these are spots far away from the application's happy path. And these are usually spots that developers don't like that much. So how can you add threat modeling to your day-to-day work? We all know that software is best built iteratively in an agile process, and you all know the arguments that software should be built in short sprints, and you add a lot of feedback loops so you can quickly react if something just runs into a problem. So why don't we also handle security like this? Moving security to the left means that security shouldn't be done at the end, but right during development. It can and should be part of the iterative development process. And for this, developers can make small threat modeling sessions on a regular basis, like every second sprint or so. And during these sessions, the developers will take the attacker's view on the system and mentally try to break things. And the result will be a list of threats which can then be prioritized according to some rough measure. And this can be the risk, so the likelihood that an attacker exploits in a threat times the consequence of an successful attack. And you can then add this prioritized list to your backlog and just treat it as you usually do with bug tickets in your agile process. And by these, security just becomes a natural part of your development cycle. So I told you that threat modeling can be a boring task if you just work off some long checklist of known attacks. And this might even prevent your developers from doing it. But it hasn't to be the case, because Microsoft invented a very, very fun way to do threat modeling, namely serious games. So they came up with the idea to play threat modeling as a card game. So they had the idea to enable developers without a very deep background in security to do threat modeling for their own application. And for this, they basically wrapped a rather comprehensive threat catalog in this nice looking card deck, and they added some rules and game mechanics such that you just apply these threats in a reasonable manner. And the most important thing here is that if you play this regularly and you do threat modeling regularly, then you step by step build up kind of awareness or intuition for security. And this will then just pay off enormously in the future when you build new features. So as I said, these card decks are threat catalogs. So each card represents one particular attack on your system. And here at TNG, we are using two major card decks. The first one is the original by Microsoft, Elevation of Privilege. And this is a rather general framework to threat model all different kinds of systems. And if you want, you can call it the Swiss Army knife for threat modeling. And the other card deck, Cornucopia, was built by OWASP. So it has a slightly different intention. So this should be used for threat modeling web applications. And it's also less abstract than Elevation of Privilege. So it's on a slightly more technical level. So this can be the easier starting point for beginners. Yeah, originally we played it here at TNG as a real card game, like with printed physical cards and people meeting in the same room and just playing the game. But then there was the pandemic and teams started to spread around between different geologies. And so we needed some kind of remote version of this game, so some online game. And there was one on the internet, which was developed at Kareem in Dubai, and which actually was pretty great, but it didn't really fit our use case here at TNG. So we started to add large contributions to that game. So for example, we added the Cornucopia card deck, and we just made small, tiny changes to the game flow, which just made it much more fit to the way we want to use it at TNG. And if you want, I can even show you a small demonstration of this. Maybe the game, it looks like this. What happened here? And now I have to find my mouse. Where is it? It's here. No. Okay, let's do it. Okay, let's do it like this. So, oh, I'm just in the wrong tab probably, but okay. Now I'm lost. So now I'm kind of lost. Well, this was fast, but thank you. So we're here. And I wanted to show this. Okay, So this is the game, and you're supposed to play this with an open Zoom channel next to it. So you want to play the game, and while doing that, you want to discuss with your colleagues that are there on Zoom, for example. You actually don't need much to do it, because all you need is kind of a graphical representation of your game, and this can be any architectural diagram, and you can better use one called data flow diagram, because this just guides your thinking along the line that maybe a attacker could use, but it doesn't have to be pretty. It can just be like this, like a dirtily drawn, badly scanned diagram written on a piece of napkin. As long as everyone can read it, it's okay, but you can also use your shiny diagrams from your wiki. And yeah, so every player gets the game, gets the one version of the game, namely he gets his own card deck. So then you can play a card and see if this particular threat applies to your system, and then I broke it. So what happened here? So, and then you can just add a thread, and then in the end, you'll just have a list of all these threads, and you can download this, and as I said, you can then just pipe it back into your agile process and well, work these things off. And then let's hope that the application gets more secure by this. So if you want to have a look at if you want to have a closer look at this, you can just check out our fork on GitHub. And yeah, what does Ben say about that?
Okay, so we've been doing regular threat modeling. That's the thing. If you do regular threat modeling, then it's a good way of securing your application. How does this move security left, you might ask? Aren't all these threats already on production? Well, maybe they are, but still, the whole point of this is that developers do this regularly and then start thinking about their system as something that's not just there to be developed and used, but also to be exploited. So that carries over into the design and the development and the planning of the software. So then it just makes our entire process from the very beginning more robust. Yeah, so we do this, and we're pretty confident that we've found and fixed most of the potential weaknesses in our system. This is more or less the application done, isn't it? I mean, we've covered the infrastructure, we've covered the software. So there may be things that we haven't spotted in it, but it'll be hard for Chris to find. What are you going to do next?
Yeah, what am I going to do next? Well, let me think about it a little bit. Maybe I have to think outside the box a little bit. So if I cannot hack the application as it runs on the server, so maybe I can somehow hack how the application gets to the server. So maybe I can infiltrate deployment. So before we spoke about the developers team, but what about the operations team? So maybe they don't really care about security, or maybe they are not skilled in what they are doing. Or maybe also for them, management didn't give them enough time or priority to set up the app securely. I mean, these people are humans, and humans make errors. And if that's the case, then I can maybe tamper with the deployment process itself. So I can maybe inject some backdoor into the app before it goes live. So I think Ben didn't really think about this possibility.
Well, we don't have an operations team. We do DevOps. And that's something that people really like to forget about. Managers particularly love to forget that their team is also responsible for operations, and running your application is probably more important, at least from a customer's point of view, than developing it. So is it a good thing or a bad thing for Chris the Hacker that we're doing DevOps? That rather depends. In a successful DevOps team, we move software very quickly from design through to production. We deploy changes quickly and reliably. And to do this, we need continuous integration and continuous deployment, or CI/CD. Those lovely pipelines again. They don't just build and test your software, but they also deploy it to production. And if your company has a successful DevOps culture, then I bet that good CI/CD is the tool behind it. But what does this mean? Well, this is not your problem. In threat modeling, you need to model your threats. And here we have an attacker attacking our pretty well secured application. But as we've shown, we've taken many measures to combat these attacks. This is more like your problem. And that brings us to the second major point we'd like to make. It's important to do threat modeling, but it's just as important to model the right threats. And in DevOps, behind every production system is another large and complex system that, at least in terms of security, is just as critical as production itself. So we should take a closer look at this.
Okay. So you have a great automated process, but what about the deployment infrastructure that is actually running this process? So you said you have this CI/CD server, and yeah, that's one thing that surely has to be able to do a lot of other things. So the CI/CD server should certainly deploy to production and maybe also to other environments, and it will maybe even handle backups, and it will surely build the application. And it's one place that many people will have to use. So the developers, maybe QA people, so many people will have access to it. And such a server just seems like the perfect target for me. I mean, this is one single place that holds all the keys to your crown jewels, and so many people have access to it. So I think I'm going to hack this now.
Yeah, deploying to production should be simple. You commit and you merge, maybe you even click a button, but then at the latest, it's reached production. And it should be a secure process, deploying. But don't forget, automated deployment means that a way of accessing the production environment, and probably your test and staging environments too, is lying about unattended because it has to be used by a machine. So it's also usable by anyone who can gain access to that machine. A very common pattern here is to have one central deployment tool that has credentials to access production, just like here. It then deploys there. It executes Terraform, kubectl, Ansible, whatever you use as a provisioning tool. It takes its keys, access production, and staging, and then carries out its scripts there, executes its scripts there. This is the deployment push principle, and it has a fundamental problem. Those keys can be taken and used by other people. You can easily mitigate this by maybe limiting the permissions that the keys, the credentials, the access credentials give you. It's easier in some clouds than in others. You could lock down your tool so that new users can't normally extract those keys. But this is difficult in a CI/CD system because developers also need to be able to execute their own code on there to run their build pipelines. You could maybe even lock down network access to your environment so that only this CI/CD tool actually has access to it using those credentials. But the keys are still there. Whatever measures you take, they're outside the environment and they're ready to be stolen. They have to be created and transferred somehow too, and that opens more attack vectors. And locking down CI/CD while leaving enough flexibility for developers to work on their own pipelines inevitably trades off security for development efficiency. So we use at least a better way in principle. This is the pull principle. And the way this works is by bootstrapping an environment to read its own configuration from a particular place. Deployment then happens using an agent within the environment itself. In most cloud providers, this is a particularly easy way of doing things. Why? Because it's simple to grant roles to resources within the environment. It's easy to have permissions to do something within a project or an account on AWS and get these permissions to some kind of pod, some kind of machine within the environment. So the deployment agent can assume the roles it needs without keys ever leaving the environment. And once your production, once your staging is up and running, there's no need for deployment access externally at all. There are no keys outside there to steal. Our way of implementing this is to use GitOps. Our configuration is stored in a Git repository. All changes to the configuration are done as a Git commit. And that has the huge advantage that you can see at a glance what the current configuration on all the environments is and the entire history of all those environments. Now, we chose GitOps because it works particularly well with Kubernetes, our tool of choice. The configuration contains the desired state of the cluster, and tooling like Flux or Argo CD takes care of applying it. But the basic idea of the pull principle works as long as you have first a trusted place to read your configuration and pull your resources from, and secondly, a deployment agent within the environment. Does this mean you can switch to the pull principle and then everything is secure? Well, of course not. It's theoretically more secure, at least if everything's done right, but whether it's actually more secure depends entirely on how it's implemented. There's, of course, a more or less powerful deployment agent running in your environment that's not strictly necessary for production. And if that is corrupted, then apart from the obvious problems, it could also fail or refuse to fetch any clean dependencies. And then your environment reaches a state where it's so corrupt, it can't be refreshed by configuration alone. But in any case, whether you're doing push or pull principle, you should always be in the position to be able to destroy your entire environment, to recreate it from scratch, and to restore all your data. And this is our approach of last resort. To do that, of course, we have to make backups, and we have to test bootstrapping regularly, and we have to test restoring data regularly. But as I say, you should be able to do this in any case. But there are two other things in this process that are still slightly concerning. I wonder if Chris the hacker will notice them.
Yeah, there's one obvious thing, I think. So Git is really important in the setup. So it drives the whole deployment process, which from then just goes automated without human intervention. But this is also an opportunity for me. So there's this single point of truth which just drives everything. So I think I'm going to hack Git, because whoever owns Git also owns deployment. So let's see what Ben did about that.
Right, Git, or version control as a whole, plays a hugely central role in DevOps. It doesn't control what code, just control what code is built and published, but through the configuration, and even if you're not doing GitOps, you probably have configuration as code, it controls what's deployed on each environment. So it doesn't pull deployment, just shift the security challenge from your CI/CD tooling to Git. Well, more like it confines the security problem to a particular part, and a part that we understand relatively well. We don't have the entire sprawling CI/CD system, which is effectively just something that executes code that developers push to it. We have a simple tool that's mostly concerned with merging and branching. And most Git-based development tools, GitLab, GitHub, all these kinds of things, they offer ways to convert these concepts about who can merge to which branches and which branches are relevant for production. You can convert these concepts into rules. who's allowed to push, who's allowed to merge, and under what circumstances. So GitOps, or using Git generally as a means of security, means that you very much limit this problem that you inherit with GitOps, with DevOps, to a more manageable place. And this is one of the approaches that we'd recommend if you can confine your security problems to a smaller area, then you certainly make your entire system more secure. It's not just tampering with Git repositories itself we have to look out for. Someone running a denial of service on our Git server could also stop our entire team from working and prevent deployments to production. And that would, for instance, be particularly bad if we urgently had to patch a security hole. So we invest in our infrastructure to shield exactly this service against such attacks.
Okay, but there's still another weakness that I see, and it's the dependencies. So configuring a server and running a service on this, well, it requires you to get a lot of things to the machine. You need things like Helm charts, Docker images, apt images, but also open source libraries from Maven Central, NPM, or pip. And this stuff usually has to come from somewhere. And this somewhere usually is somewhere on the internet. So maybe I can hack one of these repositories and inject a bad dependency. And this will then just be pulled by your environment and run on the server. Or at the very least, I could try to block your access to the dependencies. And this is then just another denial of service possibility. So this will just break your deployment.
Yeah, there are many dependencies we need. This has been the case in the past, of course. We've been doing development. You need your Maven packages or your NuGet packages or Node. It's something we're used to. But with responsibility for operations comes responsibility for containers, for operating systems, and so on. And any of those things can also be attacked with malicious software that, if you do it wrong, can be pulled at the next update and then run straight on production. So to mitigate those risks, we choose to mirror artifacts and dependencies within our own cloud infrastructure. That's often a high effort strategy. We have to define a process to select which dependencies need mirroring, which Docker images can we use, and we have to make sure we don't miss them, because that is pretty problematic when you want to deploy something or build something. And then we have to establish the connectivity between our target environments and the mirror. But it's the safest way for various reasons. We can control the rate of updates, and that mitigates risk. We don't want to be too fast and then take every hole as soon as it's released and no one's had time to check for it. But we also don't want to be too slow and miss patches for known problems. We can scan our own infrastructure, our own images for vulnerabilities, and we can protect against denial of service attacks. Particularly, it also means that we can limit the egress from our environments here. We can keep them tucked away in private subnets because we provide private endpoints to our own infrastructure. And that means, again, our application doesn't have arbitrary access to the big evil internet. But many dependency problems are not deliberate attacks. They're just due to unintentional bugs that people find and attackers then exploit. But they still land in your software. We scan for third-party vulnerabilities in our build pipeline, but the basic problem with vulnerabilities is that they can be discovered at any time. They pop up in things you've already released, and that's not even your fault. It pushes vulnerabilities right to the right of the DevOps lifecycle, to this unpredictable part of operations that need addressing right away. There isn't an entirely perfect way of dealing with this, but a good one is, again, to automate it. You can use tools like Renovate or Dependabot to move this problem further to the left, to the build part of your cycle, because they take dependencies automatically, they will include them, include the updates in your software, trigger a build pipeline, and if all the tests pass, then it may even just get deployed on production straight away without you having to do anything about it. So in most cases, it just changes from an operations problem to part of your build pipeline. So we also have measures to secure our supply chain. And while those measures are not entirely foolproof, they will still miss things. We reduce this window of vulnerability as much as we can.
So, okay, I see you're well prepared for this. So what else can I do? So let's brainstorm a little bit again. So we have seen that automation is quite hard to attack. So what about the human factor? So let's tackle the humans involved and no, what's this? Yeah, they're still the developers. So let's hack the people. So software is built by humans and clouds are operated by humans. And again, humans make errors. So let's try to focus on the developers right now. So we know that you need internet to build software. You need to read documentations, or you have to look things up on Stack Overflow. So your development machine will definitely be exposed to the internet. Therefore, it will be vulnerable. Or maybe the developers have other kinds of exploitable problems that I can just use for my evil thing. So this actually opens up a ton of possibilities. So maybe I can try to hack the development machines. Maybe I can use a good phishing attack. And again, humans make errors, and also a good developer, as clever as he may be, might fall for a well-crafted phishing scam. Or they reuse their credentials somewhere, and I can buy their passwords from some breach on the darknet. Or what about social engineering, threatening, blackmailing? These are so many possibilities, and I think Ben will just have a hard time protecting from them.
Right. People are the biggest weakness in practically any system. And our developers, they need access production. You can't expect them to operate a platform without giving them access to actually maintain that platform. They need the ability to observe it, and if necessary, they have to step in and fix things. So even in self-healing systems, in the ultimate case, you may need to give people direct access to instances or databases. But yes, as people, developers are again the most insecure thing in this system. They can be tricked, pressured, and spied on to reveal their access, and then our system could be compromised. But the answer is not to start taking responsibility away from developers, it's to invest in tooling again. Keeping people at arm's length from the system means that you can give them access and insight into how it's behaving without actually removing their closeness to operations. And what does this mean? It means good logging. It means good monitoring so that DevOps engineers can observe without direct access. And that means not just good infrastructure, but also the time and the effort early on in the build life cycle, in the software life cycle, to make sure that applications log what's needed. And it needs the effort later to create dashboards and the right interpretations of the data. So well thought out permissions, or even good deployment pipelines, they can enable developers to carry out simple actions like restarting a server without admin access to a cluster. Investing in good tooling then can reduce the need to access production considerably. Good operations tooling means, if you do it well, better security. But at some point, a real human will have to have the possibility to access production. And here, only the usual best practices can help. MFA wherever possible, clear processes, and as always, audit logs and audits. And particularly raising security awareness, threat modeling again, so that people behave as securely as people can. And in the end, there is always a way. It does not matter what measures you take, there's always a risk. You can spend hours doing threat modeling and someone comes along with a metal implement and forces your developer to give access. This is maybe our main message for today. We can show you where you might need to look, but we can't assess the risk for you. And to be honest, we can't even show you reliably where to look because everyone's system looks different. This is what threat modeling is for. You identify the threats, you consider the impact, and you see what you have to do to mitigate them.
Yeah, and in the end, that just leaves me at a point where I'm done, where I just say all this effort and all this work that I have to put into this hack are not really worth the outcome anymore, because hacking in the end is all about cost and benefit. And at some point, this is not really in balance anymore. So let's get to a summary of today. So move security to dev and don't leave it to ops. Try to include security as early as possible into your development cycle. And include threat modeling into your agile process. Because the earlier you find the bug, the easier it will be to fix. You should have an eye on the whole delivery process. Security not only concerns your production servers. There's this whole system of CI/CD, version control, etc., which can be a valuable target for an attacker. And all the same, secure development is very important, but also is deployment. And you should automate that as much as possible. You should focus on building secure software, but you can only do that if you're backed by a secure delivery process. Automating your deployment as much as possible reduces the access that you have to your production servers to the absolute minimum. And it also keeps away distractions from the developers. And these distractions are usually something that a machine can just much better handle. You should raise awareness. Security should be a natural part of your development process. And developers should not pass the buck to some security genius. They should rather take the full responsibility for the product. And this includes security, because this responsibility is what DevOps is all about. And in the end, you should constantly threat model. You should constantly assess the security of your system. And that's the system which is in development right now, as well as the system that is deployed on your production servers. And you should keep in mind that the security of your system is not really set in stone only because you have deployed it. And you should constantly verify that the security assumption that you put into your system are still valid. And for this, threat modeling is the tool of choice. So, thank you.
Thank you also from my point at that time. So are there any questions from the audience room?
So you heavily argued for putting more and more stuff into the CI/CD pipeline, in a sense, doing all kinds of checks and scans and whatever, you know, all the things you listed. I don't want to repeat them all. But this, of course, is a trade-off, right? Because if I, as a developer, have to wait for all those checks to pass to see what I've done, in terms of developing a new feature, this lengthens my feedback cycle, which I, as a developer, might not like. So what are your thoughts on that?
Sure, that's a possibility. I mean, as you say, it's a trade-off. You can take also measures to make sure that you parallelize these checks as much as possible, and that just reduces the time. Then it's more of a win-win situation. You put more in your pipeline and it doesn't take longer. It's the magic of computing. But sure, I mean, some things just take longer. If you want to do dynamic analysis, fuzzing, this kind of stuff on your application, this takes a long time sometimes. It's not something you want to run on every pipeline. So maybe define different cycles, Some things are maybe done just before production. That's the important thing, what's released to production. And what developers do in their own individual development cycles, that can be shorter. It just depends how much confidence you want to have after each build pipeline runs that your software is actually secure.
Then maybe one question from the world outside of this room. Stefan Weber is asking how to secure that you are not using hack tools like IDEs and stuff like that on your computer.
You mean that the IDE itself is not?
At least I assume that that's what he means.
Yeah, I mean, this can be a well-detect vector because usually IDEs like, I don't know, IntelliJ, VS Code or whatever, they use plugins, and all these plugins, they can do stuff. And it's, if you look at the security concept of VS Code, for example, it's quite scary what such an extension is allowed to do. And I mean, you can try to put your IDE into some kind of jail, like a fire jail or so. I personally played around with this a little bit, but it didn't work so well. So in the end, I think the best approach is to have as few extensions on your IDE as you can, and you should verify that they come from a trusted place.
Perfect. Then I would like to thank you again. We also have a small little present for you for your effort. And with that, I would say thank you very much for your time and enjoy the rest of your tech day.
Thank you.